Hello, I am Dr. Chittaranjan Mondal. In this video, I am going to discuss continuous probability distribution. Let us take an example. That is, I am going to take an example to discuss this our topic. So that a function mod x where x belongs to -1 to 1 open interval and 0 elsewhere is a possible probability density function, that is PDF in a short form. And find the if this is probability density function, then find the corresponding distribution function. So first of all, it is given to us the function mod x belongs to -1 to 1. So here we can write f of x equals to mod x where x belongs to -1 to 1. So this means actually x belongs to -1 to means actually strictly less than 1, strictly greater than -1. So and we know that mod x means always positive value. So we split this because -1 to 0 this is negative, x is negative, and 0 to 1 x is positive except 0. So we split this function. So x, when x positive including 0 because at 0 the function itself 0. So because of x here. So 0 and -1 to 0, so this is -x, that is positive value, and it is given this function elsewhere, this is 0, so and 0 elsewhere, that is elsewhere in this case here -infinity to -1 open union actually 1 to infinity. That is in this range. If x belongs to in this range, the functional value is 0. So now we have to show this function is possible density function or not. First of all, to show this, we have to show the properties of the density probability density function f of x 1, f of x greater than equals to 0 for all x, 2 -infinity to infinity f of x dx, that is the integration, is 1. We have to show this. So from the given function it is easily understand, or easily we can say that the function is positive for all case, for all 0. Elsewhere this is 0 and at 0 this is 0, and except 0 and all other values of x always 1, that is not 1, positive value. So this is obvious case. Second one we have to show, so integration of the function -infinity to infinity is 1. So let us check. So here the limit -1 to 0, 0 to 1 and elsewhere, so that is -infinity to -1 f of x. If we write -infinity to infinity f of x dx, we can split in this way, dx plus -1 to 0 f of x dx plus 0 to 1 f of x dx plus 1 to infinity f of x dx. So -infinity to -1, the functional value is 0 because of elsewhere this is 0, and also this is 0 because x lies between -1 to 1. So now in -1 to 0, this is f of x is -x, 0 to 1 f of x is x. So -1 to 0 -x dx plus 0 to 1 x dx. So that is -x square by 2 if we integrate this, and limiting value -1 to 0 plus x square by 2, this is limiting value 0 to 1. If we put the values minus, that is 0 minus half plus 1 by 2 minus 0, that is half plus half, that is 1. Hence we can say that therefore f of x is a probability density function or PDL. So using these two properties we can say this is probability density function. Now we are going for the next case, find the corresponding distribution function. So here distribution function, so f of x is minus infinity to x f of x dx. So now we consider the range x first, minus infinity to minus 1 in this case. So minus infinity to x, if x belongs to minus infinity to minus 1 f of x dx, in this case the functional value is 0. So minus infinity to x 0 dx, that is 0. Second one, we consider the second range. The next range f of x is minus infinity to x f of x dx. Here x minus 1 to 0. So now minus infinity to minus 1 f of x dx plus minus 1 to x f of x dx, where x belongs to minus 1 to 0. Sorry, here equality sign. In this case, this is 0 because it is defined in the question. So for this case, minus 1 to x, f of x is minus x dx. If we calculate this, minus 1 by 2x square, that is minus 1 to x. If we put here minus half x square minus 1, that is half of 1 minus x square. In the range, the distribution function is, in this range the distribution function is half of 1 minus x square. So next range, corresponding the range, next range the distribution function is x f of x dx. The range is x 0 to 1. So in this case, again minus infinity to minus 1 f of x dx plus minus 1 to 0 f of x dx plus 0 to x f of x dx. This is 0, and we already integrate this one except the limiting value, this one. So we can put here minus half x square minus 1 to 0 plus, in this case, 0 to x dx. So that is, we can minus half, in this case 0 minus 1 plus x square by 2 0 to x, that is, here this is 1, half only, and this one plus only x square by 2. So we can write 1 plus x square 2. Now the next range, 1 to x, 1 to infinity. In this case the distribution function is f of x minus infinity to x f of x dx can be split as minus infinity to minus 1 f of x dx plus minus 1 to 0 f of x dx plus 0 to 1 f of x dx plus 1 to x f of x dx. This is 0, this one also 0, and this one here. We already integrated before. This is minus half x square, this is half x square. So minus half x square, that is minus 1 to 0, plus half x square, this is 0 to 1. If we integrate, put this value, the limiting values, we can get half plus half, that is 1. So therefore our distribution function is, distribution function is 0 when x belongs to minus 1 to infinity, minus infinity, and 1 minus x square by 2 x minus 1 0, 1 plus x square by 2 x 0 less than 1, 1 x 1. This is our distribution function. So here we can stop this problem. Thank you.